Okay, so here in this problem we have a quadratic term and a linear repeated term. So therefore the numerator of the quadratic term has to be linear. And since we have a repeated linear term, we have to write it twice. So now I'm just going to change my thickness a little bit, and I'm going to multiply both sides by the common denominator. So that's x squared plus 1 times x minus 1 quantity squared. So left hand side is equal to 4 minus 2x. The right hand side is ax plus b times x minus 1 squared plus c times x minus 1 times x squared plus 1 plus d times x squared plus 1. So the smartest thing in this case we can do before we do a lot of the other work, the heavy lifting, is let's just let x equal 1, because then all these terms will go away. So I'm going to let x equal 1. So I get 4 minus 2 is equal to, well, this is just 1 minus 1, which is 0, so that means this goes away. 1 minus 1 is 0. This just goes away. So I'm just left with 1 squared plus 1 is d. So I get 2d, right, because 1 squared plus 1 squared is 1 plus 1 is 2, so 2d. So I get 2 equals 2d, and d is equal to 1. We can let x equal 0, because that's kind of a nice easy number. I get 4 minus 2 times 0 is 0. And over here I get a times 0 is 0, so I'm just left with b times negative 1 squared. I plug in 0 here, I get negative 1. And I get 0 plus 1 is just 1. And I already know d is equal to 1, so I get 1 times 0 plus 1. So I get 4 equals, this is just b minus c plus 1. And so if I bring the 1 over, I get 3 equals b minus c. So I'm always a big fan of using a number that cancels stuff out, and then I always like using 0, because a lot of times nice things happen. Unfortunately, in this case, you'll see in a minute that this doesn't really help us out much. Next thing I'm going to do is I'm just going to multiply this big mess right here. I'll do it off camera so you don't have to stare at me watching it. Stare at me doing it. Okay, so we have some cube terms, which are here. We have some squared terms, which are here. And we have some linear terms, which are here. And I think that's it. And then we just have the constant terms left over. So I'm going to rewrite the left-hand side as 0x cubed plus 0x squared minus 2x plus 4. I'm going to put all the x cubed terms together, so that's a plus c. The x squared terms together, which is negative 2a plus b plus c plus d. And then the linear terms, I get x, and I get a minus 2b plus c. And my constant terms, I just get b minus c plus d. So since 0 is my x cubed term, so therefore a plus c is equal to 0. So a plus c is equal to 0, so a equals negative c. I get negative 2a plus b plus c plus d is equal to 0 as well. I get a minus 2b plus c equals, negative 2. And then b minus c plus d is equal to, that should be a plus sign right there. So let's just keep in mind that we know d is equal to 1, and 3 equals b minus c. So I'm just going to move the screen here. So here I know that d is equal to 1, so I'm going to rewrite this as negative 2a plus c plus d plus 1 equals 0. So negative 2a plus b plus c equals negative 1. Nothing helpful here, except that a is equal to negative c, and if I plug negative c in here, I'll just be left with b, so I'm going to do that. So negative c minus 2b plus c is equal to 2. These two c's cancel. I'm left with negative 2b is equal to 2, so b is equal to negative 1. Here I know b is negative 1 and d is equal to 1. So negative 1 minus c plus 1 for d is equal to 4. These two cancel out, so I'm left with negative c equals 4. C equals negative 4. And since a is the opposite of c, it must mean a is equal to 4. Alright, minor mistake. I hope you picked up on it. This is negative 2, so therefore we have negative 2, so b is equal to 1. So that means we have b is 1 and d is 1. So that means if I subtract over the 2, I get 2, so c is equal to negative 2. So let me just scribble this out because I'm sick of this problem. Since a is the opposite of c, that means a must equal 2, and I'm finally done with this problem. That was annoying.